Welcome back. The next video is focused on question 2, 3, and 4. What is the associative property of multiplication? Right, so associative property basically refers to something where you have a sequence of multiplication and you don't really care about the order. You'll still get the same answer. For example, let's say 3 times 2 times 1. If you had to say 3 times 2 first, you'd get 6, and 6 times 1 would still give you 6. On the other hand, if you had to go 1 times 2, you'd get 2, and that same answer times 3 will give you 6. So the order in which you multiply does not matter. It simply states that you can multiply in any order or any two numbers first. So which one would be the associative property of multiplication? So let's look at this one first. This is 2 times 4, 2 times 3 plus 4. From what they have here, it seems that we have taken the 2 and multiplied it by 3, and then taken the 2 and multiplied it by 4. 2 times 3 and 2 times 4. This is called the distributive property. It's where we distribute the 2 to the 3 and the 4, which is not what we are being asked for here. However, if you look over here, we have 3 times 4 times 2. 3 times 4 times 2. This is the sum we are faced with. And we have, let's say, one friend saying, let's do 3 times 4 first, and then times it by 2. And a different friend saying 4 times 2 first, and then times that by 3. And they should get the same answer. That is according to the associative property. 3 times 4 will be 12, and 12 times 2 will be 24. Whereas here we'd have 4 times 2, which is 8, and 8 times 3 is 24 as well. So the associative property of multiplication is this one over here. The next part is additive inverse, where we are required to find the additive inverse of the following numbers. The question is simple. We need a number that makes the statement true, because by definition a number plus its additive inverse have to equal to 0. So if you choose any number, you have to add a specific number which is called the additive inverse, and the answer will be 0. So let's think about this. 3 plus something should equal to 0. So most people can say, okay, 3 minus 3 would give you 0, and that is correct. So 3 plus negative 3 would give you 0. That would make the additive inverse of 3 negative 3. What about 2 over 5? 2 over 5 plus negative 2 over 5 would give you 0. So there's a pattern here. The pattern is quite simple. The pattern is that we are using the same number, but we are just changing the sign. Where it was positive, we made it negative. Where it was positive, we made it negative. When it was negative, we made it positive. Negative, we made it positive, and positive to negative. And that would be our additive inverse. So for additive inverse, all you have to do is change the sign, and that will be your additive inverse. Let's have a look at our multiplicative inverse now. The multiplicative inverse means that a number, any number, times a specific other number, the multiplicative inverse basically, should equal to 1. Now, the number 3 times something should equal to 1. Now you might be thinking that 3 times anything, there's no way to get it to 1. But what if you had to say 3 divided by 3? Wouldn't that be 1? So using that concept, we can say 3 times 1 over 3, which is effectively 3 divided by 3. 3 times the reciprocal, which is 1 over 3, will give you 1. So the multiplicative inverse we're seeing a different thing happening now. This is different from your additive inverse, so don't mix them up. Now, on this concept, what do you think the multiplicative inverse of 2 over 5 would be? 2 over 5 times what would give you 1? Take a minute to think about it. Alright, so if you are along the lines of saying maybe trying to change those two numbers in some sequence, you would be there. The answer is simply 5 over 2, because what's gonna happen is you got 2 divided by 2 and you got 5 divided by 5 in the same sequence. So all we had to do here was flip the fraction around, change the order of the numerator and the denominator, flip them around, and you've got your multiplicative inverse. So we're noticing that there's no changing of signs happening for the multiplicative inverse. That only happened for our additive inverse, and for our multiplicative inverse all we have is a flipping of a fraction. So negative 7 would become negative 1 over 7. Negative 3 over 7 would become negative 7 over 3. 11 would simply be 1 over 11. Alright.